Hello guys, welcome back to the channel. In today's lesson we will learn about partial fractions and binomial expansion in detail. So before we start this partial fraction, you need to know about the what you have learned at your IGCSE level. So you have learned how to add and subtract the algebraic fractions. For example, you have done like 5x plus 3 equals to 4 x minus 2. So you have learned how to solve this. So I am not going to go in detail. So when you combine these terms by taking this LCM, we got it, the answer is going to be 9x plus 12 over x plus 3 and x plus 2. So you have learned like this. So we have converted these expressions into as a single term. So now partial fraction are the reverse process. So you are given here 9x plus 12 and you are going to split this into this. So basically partial fractions, it's a reverse process to decompose the algebraic expressions, right? So we have different rules for that. So we will discuss that one by one. The first one we have here, partial fraction of type 1. An algebraic fraction with linear factor in the denominator can be splitted into partial fractions this way. So you need to look at the denominator. So denominator is the one that decides how we are going to split. There are certain rules for that. So if you see two linear expressions in the denominator, then you will have a over x plus b and b over x plus q. Then we will find out these a and b, which are the constant according to the given terms. Like here we have this example. So I am taking this example, express x plus 3 over x minus 2 and x plus 1 in a partial fraction. So as I said, this is type 1, partial fraction of type 1. So we are going to split. I am writing here x plus 3 over x minus 2 and then x plus 1. This is going to be equivalent to a over first factor, which is x minus 2, then plus b over the second factor, which is x plus 1. So we can write it like this. So let's say this is equation 1. So now we will find out the values of a and b, the constant. So there are two methods. I will show you both of them. So the first method that we have here to find out the values of this. So first of all, you multiply, cross multiply. When you cross multiply, you will get x plus 3 is equivalent to a, and then you will have, when you bring it here, so you have x minus 2 and x plus 1, and over we already have here x minus 2, and then we have plus b into, it's going to be both factors, x minus 2 and x plus 1, and in the denominator we have x plus 1 already. So this is cancelled and this one is cancelled here. So we have here x plus 3 is equivalent to a into x plus 1 plus b into x minus 2, right? So this is from here, from this step we are going to have the final values of a and b. So now you can suppose, let's say I want to make this as 0. So I will take x equals to negative 1. If I take x negative 1, what will happen? So this left hand side is going to be minus 1. I am replacing x by negative 1 plus 3 equals to, then we have a, and x is negative 1 plus 1. So you can see this term will vanish because we have this 0. 1 minus 1 is 0 over here, and b is negative 1 negative 2. So we are going to get here 2 as this is 0, I am leaving it, and then we have b into negative 3. So from here we get b as 2 over negative 3. So I will write here negative 2 over 3. So we got the value of b. Now similarly we can get the value of a. So let's say now we vanish this next term. So to vanish that term, so what we are going to do, we are going to take the value of x that way. If I take x equals to 2, so then this is going to become 0, right? So then we will have here x plus 3, that is the left hand side, sorry, we can put the value of x. So x is 2 plus 3 equals, then a into x is 2 plus 1, and then b, that is 2 minus 2. So this will become 0. This is 5 and this is a times 3 plus 0. So basically we got a as 5 over 3. So we got the values of a and b. Now we can substitute this equation in equation 1. So from 1, what do we have? From 1 we will have x plus 3 over x minus 2, and x plus 1 is equal to a over x minus 2. A is 5 over 3. So it can be written as 5 over 3 into x minus 2. Then b is negative 2 over 3, I write here, and we have x plus 1 like this. So this is our final answer. Now you can see that we have splitted this the fraction, this fraction into two different terms. So there we had only one as a whole, and now we have splitted it into simpler part. So this is one method to solve this, to find out the value of a, b and a, b or whatever constant you have. So now I will show you the second method. So second method to do this is we can have this, I'm rewriting the one when you I'm rewriting this expression from here. Let's say this is equation 2. So I'm taking this x plus 3 is equivalent to a into x plus 1 and then plus b into x minus 2, right? So now for the second method, what you do, you expand this right hand side to equate the coefficients. So when I expanded this one, it will become ax plus a and then plus bx minus 2b, right? So here we have terms of x and constant term on left hand side. So I will bring the x terms together which is a plus b into x, then the constant terms a minus 2b. Now we are going to equate the coefficients. When you equate the coefficients, both sides, we have here, we are going to have a plus b equals to 1, because this is coefficient of x, here coefficient of x is 1, and the constant term is a minus 2b equals to 3. So from here we can get the value of a. So we have here, you can solve in any way. We have, these are two simultaneous equations. Now you can get the value of one and substitute in the other, or you can even solve it as a simultaneous equation to find out the value of a and b. I am taking here a equals to 1 minus b, then I will substitute this value here. So a is 1 minus b minus 2b equals to 3. So 1 minus 3b equals to 3. So then we have negative 3b equals to 3 minus 1, which is 2. So b is 2 over negative 3. So we got the value of 2, negative 2 over 3, and a is, then we substitute back this value, b is negative 2 over 3. So which gives us a is 5 over 3. So we got the value of a and b. So that's how we are going to use. Then again you see we got the same value of a and b as we got here, negative 2 over 3 and 5 over 3. So then we can have this will be our final answer. Again we are going to put. So this is how you use your two different methods to find out the values of the constant. But Personally, I feel that the method 1 is bit easier. So you can make one of the terms 0 by getting the values of x. Then I will use in further questions this method 1. So you can let me know in comment section which method is your favorite, method 1 or method 2. Now we have this example here. Okay, this is done. So another example on that, here we have express this x over 1 minus x minus 2 square. Now if you look at the first side here, you will find that denominator is not a linear function, but we can split that, we can make the factors of that. So 1 minus, by making the factors here, 1 minus, I am rewriting it, it is negative 2x squared minus x minus 1. So when you make the factors of this is going to be, we need here the term as negative 2 and then negative positive 2 and a negative this 1 here, right. So the factors of this is coming 1 plus x and equals to 1 minus 2x. So we can replace this by this x, that fraction we are given 1 minus x minus 2x square. So we have converted this into type 1. So this is, you can see now in the denominator we have only the linear factors 1 plus x and 1 minus 2. Now we will use the same method. So I am writing here using partial fraction of type 1. This is of type 1 method. So we have x over 1 plus x, then we have 1 minus 2x is equivalent to a over the first factor plus b over the second factor, right. So now we will cross multiply, we are going to multiply here by this. So this gives us x will be equals to a. With practice you will learn, you can skip some of the steps here. So I am just writing here, it is 1 plus x, so that you understand everything. B into 1 plus x, both the factors, 1 minus 2x over 1 minus 2x, right. So this 1 plus x is gone, here 1 plus 2x is gone. So we are left with x is equivalent to a into 1 minus 2x plus b into 1 plus x. Now we will take the values. So this is our fraction that when we splitted, and when if I take let's say x is equal to negative 1. So this will be negative 1, left hand side equivalent to x into 1 minus 2 times negative 1 plus b into 1 minus 1. So this will become 0. So negative 1 is equivalent to this is 2 times, it is positive 2 plus 1, it's 3a. So this is going to become 3a. So that gives us a as negative 1 over 3. So we got the value of a now. So now we can look for the value of b. So to make this term here 0, the first term here, this to make this 0, if I put 1 minus 2x equals to 0. So from here 2x 1 will be 2x and x will be 1 over 2, meaning if I substitute x as 1 over 2, I will make this as a 0. So now secondly we will say, let's say f is 1 over x is 1 over 2. So then the left hand side is 1 over 2 equivalent to x, a into this will become 0 plus b into 1 plus 1 over 2. So this is 1 over 2 and this will be 3 over 2b, right. So then b is going to be equals to 1 over 3. So this is 1 over 2 times 2 over 3. So we got b as 1 over 3, right. So now once we got the values of a and b, we will go back to the starting point where we splitted this into two parts. So I will be using this equation to get the final answer. So hence our answer is going to be, final answer is x over 1 plus x, and we had 1 minus 2x. So this has become now negative 1 over 3, 1 plus x the first factor, and then you have 1 over 3 into 1 minus 2x. So that is it, right? I hope that's clear. Please take a moment to give your feedback in the comment section if you understand that, and kindly also subscribe to the channel if you are getting the benefit of these videos. Now the next type, there is type 2 partial fraction. So for that type 2, we again will look at the denominator. So as you see, denominator we have, this is a repeated root. Whenever you see square on the expression, you will see that is a repeated root, so it has the same root. So algebraic fraction with the repeated factor in the denominator can be splitted by this way. So a over x plus p, then a over x plus p square, b over this square. So now we can take the example doing this. So it doesn't matter here on the numerator you have 1 or you have this or any expression, sorry, any expression, yeah, any expression there, right? Sorry, I just remembered one thing, the method that we have done here. So this can also be splitted for 3 factors. So if you get here like this one, if there is another factor here, let's say this factor, if you get here like x plus p, x plus q, and you may have another factor plus r, then we split it x into first a over first factor, b over then second factor, then c over the third factor, like x plus r in this case. Okay, so this is applicable for as many factors as you have in the denominator, right? So now let's go back to our question that we were doing. Okay, so 3x squared plus 2 over x into x minus 1, we are expressing this as a partial fraction. So now using this type 2 rule here, so this 3x squared plus 2 over x into x minus 1 squared. Now you see, this is now the combination, you have x as well as this. So this is repeated root and the first one as it. So we are going to combine both of them. So this then is going to be a over the first factor, which is x, then b over, using this one now for the second part, b over x minus 1 squared, and then c over, sorry, not square, square we will write in the second, here will be x minus 1 squared, right? So now we will again simplify the same way we did previously to find out the values of a, b and c. So I think now you understand. So we can write it down, 3x squared plus 2 is going to be equivalent to a, because this factor is going to get cancelled here. So we will have x minus 1 squared, and b into x minus 1 will cancel, we will have x into x minus 1, and then we have c x. Okay, so this is going to be, this is our original equation, this is going to be helpful to find out the value of a, b and c. So now as I told you, I'll use method 1. Now if x is equal to 1, then this term is going to become 0. So x is 1, so we will have left hand side like this, and this is 0 plus x1, this will also become 0 plus cx. So this gives us, as this is 3 plus 2, it's 5, equals to c. Sorry, x is 1 here. So c, we got c as 5. So value of c we got 5. Now using another this factor to make it 0, if I put x 0, let's say x is 0, when x is 0, then left hand side here is going to become 0 plus 2 is equal to a into 0 minus 1 squared. Then this term x is 0, so this will become 0. this x is 0, so third term is 0. So from here we get x a is equal to 2, right? So we got a and c. So once you got a and c, then we can substitute this value in this equation. So let's say this is second equation. So we have to have, because you cannot take another value of x here, then it will become make it a 0. So x is now, we can find out this by substituting this value over here. So other way, okay, yeah, we can, you can combine also. Let me do the way we are doing it. So a is 2 so we have 3x squared plus 2 is equal to a is 2, then x minus 1 squared, and b is, we are looking for x into x minus 1, and c we got 5x, like this, right? So now if we go to expand this, it's gonna take time, so I can just take the coefficients. So if I take the coefficient of x squared, on left hand side it's 3, so coefficient of x square here, I think I should expand before making you confused. So this is going to be x squared minus 2x plus 1, and then b x squared minus x plus 5x. So I have just splitted this. So now we can equate the coefficients of x square here, equating coefficients of x squared on both sides. So left hand side I have 3 here, this side we will have 2, and this side we have b, right? So from here we got b is equal to 3 minus 2, that is 1. So we got the value of a, b and c. So we are just going to substitute. So we will use equation 1 here. Equation 1 here is 3x squared. I will just rewrite everything from 1. We have 3x squared plus 2 over x into x minus 1 squared, and this we got the values of a, b and value of c, right? So I hope that's very clear. So this is our final answer, right? Now we have here another example, 2x over x plus 3 in a partial fraction. So again you can see this is a repeated root in denominator. So we will use this type 2 x plus 3 and squared. This is going to be equal to x a over x plus 3. Then we will take b over x plus 3 squared, right? So we are using the same that we used in the previous question. So now the cross multiplication, 2x we are going to multiply this on other side. So this is going to be a into x plus 3 and plus b. Now equating the coefficients, it's easy here. Now also you can yeah, I think equating the coefficients is very easy here. Ax plus 3a plus b, right? So here x is 2 and a is 1. A is the coefficient of x. So equating coefficients, I got a is equal to 2. So value of a is 2 I got here, and value of this is constant. Constant is 3a plus b. Other side you see there is no constant, so that means that is 0. So as a is 2, so 3 into a is 2 plus b equals 0. So this gives us b equals to -6. So then we are just going to substitute here in equation 1. So the final answer of this is 2x over x plus 3 squared equals to a. A is 2 over x plus 3 and b is -6 over x plus 3 squared. So that's it for this, right? I hope that's very clear now. Now let's move to the next one. We have partial fraction of type 3. So now what is this third type of partial fraction? So you will find the quadratic factor in the denominator. You will find a quadratic factor in the denominator that can be splitted into the following way. So actually this is linear and this is quadratic. Now you see, let me go back, so don't get confused with this. Here we had the square outside the bracket, right? So this is the repeated root. You see, square is outside the bracket. Now in this type 3 we have square inside, so meaning we have the this quadratic factor as well here. So x square is inside the bracket, so that belongs to only this x, right? So in this case we split a over the first factor, then bx plus c over x square, the plus q, that the second factor. So now we will use this method to solve this equation. 2x squared minus x plus 6 over x plus 1 and x squared plus 2. So by using this type 3 partial fractions, a over the first factor is x plus 1, then plus bx plus c over the quadratic factor that you have, which is x squared plus 2, right? So we got this one. This is the first equation where we will put the values of a, b and c. Now multiply the denominators on other side. So we have here 2x squared minus x plus 6 is going to be equal to a into x squared plus 2 and plus bx plus c. This squared factor will be cancelled. We will have the linear fraction like this, linear factor, right? So now we can substitute. To make this 0, I can put x equals to 1. So sorry, negative 1. If x is negative 1, so what will happen? So this left hand side is going to be 2 into negative 1 squared minus 1 plus 6 equals to a minus 1 squared plus 2 plus b into negative bx, sorry, b into negative 1 plus c, this is one bracket, and then x is again negative, oh, this is 0. Actually we have not even to write down, so this all becomes 0. So this is 2 plus 1 3 plus 6 9 equals to this we have 3a. So from here we got a equals to 3, right? Now for the values of d, b and c, we can equate the coefficients as well. So it's easy here because there is no actually need to expand the bracket. So I am equating the coefficients of x squared. So here x squared coefficient on left hand side is 2 and right hand side we have here this is x a, this is going to be a x squared, so we are taking the coefficients, and then we have b x times x, it is going to be b, a plus b, right? So now a is 3, then we can find out b. So then b becomes 2 minus 3, it is negative 1. So b is negative 1, right? Now equating the we got a and b. Now we can find out c, equating the constant term. So when you equate the constant, so we get the constant term here is 6 on left hand side. Right hand side we will have, when you multiply here, this is going to become 2a, then plus you have c into 1, 2a plus c. So now we have the value of a, that is 2 times 3 plus c. So from here we got c equals to 0. So value of c 0. So now we will just substitute all these values of a, b and c in this first equation. So from 1, what am I getting? The final answer. So from 1 I have here 2x squared minus x plus 6 over x plus 1 and x squared plus 2. This is going to be equivalent to 3 over x plus 1 minus x over x squared plus 2. So just substitute the value of a, b and c to get the final answer, right? Now another example we have here, you have the quadratic in the numerator as well, and denominator we have the cubic, we will get the cubic function here. So now again we have one quadratic factor, so we will use this type 3 again, x 5x squared minus 5x plus 4 over the denominator. This is 2x minus 1, 3 minus x squared. This is equal to a over first factor 2x minus 1 plus bx plus c over the second factor, which is 3 minus x squared. So this is the one. Now we will multiply the denominators on other side. So I got here 5x squared minus 5x plus 4 will be equals to a. This factor is going to get cancelled. So we have x squared, then plus bx plus c, and we got another factor 2x minus 1. So now, so we have this one here. So to find out this, we can eliminate one of the terms here. If I put x equals to eliminate this, like if I put x equals to 1 over 2, then it's gonna become 0. So let's say if x is equal to 1 over 2, so what will happen? So x 1 over 2 on the left hand side, 5 into 1 over 2 squared minus 5 into 1 over 2 plus 4. This is going to be a into 3 minus 1 over 4 it will become, because 1 over 2 square, then plus b into x is 1 over 2 again, plus c, and then times 0. So this is going to become 0. So actually there is no need to write down the second term whenever you get 0 in that case. So here it is now 5 over 4 minus 5 over 2 plus 4 equals to, this is going to be 4 times 3, 12, 12 minus 12 minus 1, 11. It's 11 over 4a plus 0. So now take LCM on this side here. It is 4, that you can also use your calculator. 5 minus 2 times 2, 4, 5 times 2, 10, plus 4 times 4, it is 16. 11 over 4a. So then we get here, this is 16 plus 5, 21 minus 10, it's 11 over 4 equals to 11 over 4a. So basically we got a equals to 1. So value of a is 1, right? Now we equate the coefficients of x square. Previously I told that I will not be using the second method, but sometime we have to, you know, combine them, the coefficients of x squared. So coefficients of x squared on left hand side we have here, it is 5 here, and here it is going to be from here, and here when you multiply this we are going to get, right? So that is going to be 5 equals to minus a plus 2b. So we got a is 1 plus 2b. So this gives us 2b equals to 6, and b is going to be 3. So we got value of b 3. Now we are left with c. So for again similarly we can equate the constant term. So when you equate constants, so then we get here 4 equals to 3a minus c, and that gives us value of a, we have 3 times 1 minus c. So then c is going to be equals to minus 1. So we got the value of a, b and c. So we will substitute in this equation 1 here, then we will get the final answer, right? So final answer is going to become this whole thing which we have here, the question. You just copy the question, whatever you get here, 5x squared minus 5x plus 4 over 2x minus 1, then we have 3 minus x squared. This is equivalent to 1 over 2x minus 1 plus 3x minus 1 over 3 minus x squared. So this is the final answer. Now next we have partial fraction of type 4, which is an improper algebraic fraction. Now before we move to this topic, you need to understand what is improper algebraic fraction. Now let's say I'm taking one example of the simple fractions. 3 over 4, this is proper, right? So you know that because the numerator is less than the denominator. Now if I have, let's say, 5 over 4, so this is improper. How we define this improper? Because numerator is greater than this denominator. So this can be written as, when you divide 5 by 4, we get 4 times 4 like this. So we write it 1 over 4, or we write 1 plus 1 over 4. So similarly we define here the improper partial fractions, improper algebraic fractions as, let's say let me give you example. Let's say we have px is a polynomial over qx. So when the degree, we define by the degree. So when the degree of px, meaning degree of the numerator, is greater than or equals to degree of qx, then this is defined. So we define it by the degree. So meaning, let's say if I give you example, let's say we have x cubed minus 2x plus 3, it is divided by 2x plus 1. So degree here in the numerators degree is 3 and denominators degree is 1, x raised to power 1 here. So then this is an improper fraction. So first we can convert by dividing, like this we did in the numbers. We will divide this and then we can use the previous methods, or directly we have here. So we can see improper algebraic fraction occur when the polynomial of degree greater than or equal to n is divided by another polynomial. I have just explained you into other words. They can split into partial fraction by first doing long division method and then splitting the remainder into partial fractions using one of the techniques that we have in type 1, 2 and 3, right? So we will use this one. This can be used directly. If you don't want to divide first, then we can directly take this a plus bx plus c over first factor and times the second factor. So let's go through the examples for more understanding of this. So we have this example, x squared plus minus x plus 5 over this in partial fractions. So now we can assign the values to x to find out the values as we did previously. So you can see that we have the polynomial of degree 2 divided by another. So here the degree of the, look at the degree. So degree of the numerator is equal to 2 and degree of the denominator is also 2. When you multiply here x times x, it becomes 2. So this is improper fraction, right? So for improper fraction, either you divide or you can use directly. So let me use first the long division method. So I am writing here this again, x squared minus x plus 5 over x minus 1 and x plus 2. So if I combine, expand the denominator brackets, so I am getting here we can simplify, we can just multiply, then this is becomes x squared, then plus 2x minus x minus 2. So this is x squared. It will make you more clear. Like this, we have x squared plus x minus 2. So we got this one. Now you see degree here is 2, here is 2. So this is improper. So we can use long division method to divide this. So let me do it on side here. So we have x squared minus x plus 5. We are dividing it by x squared plus x minus 2. So when you divide it here, we are going to have 1 here. So when you multiply x squared plus x minus 2, Now we subtract here, change the sign of the lower equation. This and this gets cancelled, this is cancelled. 5 plus 2, it is no, sorry, this we have negative sign, so this is negative 2x plus 7. So this equation now can be written as, therefore we can write x squared minus x plus 5 over this x minus 1, and x plus 2 can be written as 1 plus, we will have here negative 2x plus 7 over this, the divisor is x squared plus x minus 2. Now here you need to go back, because this we need the factors here, so these factors started from here, so that means basically it came from here. This is negative 2x plus 7 over the factors of this is x minus 1 and x minus 2, right? It's like that. So now we will again use the type 1 here. So it is x squared minus x, allow me to write this again here, x minus 1 and x plus 2, right? So we got this is the partial fraction. Now this one here, this is type 1, right? The one we did in the beginning, and we will split it accordingly. So we will take only this part. I'm just taking this part only. I'm just taking this part here. So therefore we will take negative 2x plus 7 over x minus 1 and x minus 2. This is equivalent to it is going to be a over first factor type 1 x minus 1, then plus b over x minus 2, right, the second factor. Now we will find out the value of a and b. When you take the denominator the side, I'm going to get here this is 2x, negative 2x plus 7 will be equivalent to x a into x minus 2 plus b into x minus 1, right? So we got this one. So let's say our x is equal to 1, then this is going to become 5 on left hand side, and x is 1 here, so 1 minus 2, and this is going to become 0. So this gives us a is equal to 5 over 3. X is 1, this was plus, sorry, it is plus here. Yeah, so we got a equals to 5 over 3. Now say let's say x is equal to negative 2. So when we put negative 2, we are going to get this factor as 0. So x negative 2, we get left hand side as 11 equals to then this is 0 plus b into minus 3. So this gives us b equals to negative 11 over 3. So b is negative 11 over 3. Now we are done, right? So then we will take it from equation 1 here, this one here, that one we take here. So this is going to give me the value as x equals to x squared minus x plus 5 over x minus 1 and x plus 2 equals to 1 plus 5 over 3 into x minus 1 minus 11 over 3 into x plus 2. So this will be our final answer, right? So we have used here in the in this example the long division method. So apart from long division, you can directly use this also, but it will give you the same answer, right? So I hope that's clear now. Now this one here, find the value of the constant a, b and c such that we are given this already, right? So we are looking for the value of a, b, c, d here. So we have a polynomial of degree 3, this is degree 3, which is divided by another polynomial of degree 3 here. So that means this is improper, so we can use long division method to this one. So if I have here, this is 3x squared plus 2x squared plus 6x plus 4. If I expand the denominator, it is x cubed plus x squared. So we are dividing this 3x squared plus 2x squared plus 6x plus 4. We have x squared plus x cubed plus x squared. So we are dividing by this. I need 3 here, so I will multiply by 3. So this is going to become 3x actually. We have x cubed, no, only 3. This we have only, sorry, I have written here 3. Yeah, this is 3. So by 3, when you do this, then 3x cubed plus 3 times this is 3x squared, right? So when you subtract, this is gonna be subtracted, it is negative x squared plus 6x plus 4, right? This is what we got. So I can rewrite this one here. So this is 3, we got 3 here, 3 plus, then we have negative x squared, that the remainder, plus 6x plus 4 over, then the divisor was x cube plus x squared. It can be written as again in the previous form, x squared into x plus 1. So now we can see from here, this, if you compare the right hand side, we already got as a equals to 3, right? So once we got a equals to 3, then I can take the second, this we will deal just with the second term here. So the second term that we have here, it is this one, right? So this is minus x squared plus 6x plus 4 over x squared into x plus 1. So we can split this into using the repeated factor, and we have repeated factor and a linear factor. So we will be using this division here, b over x plus c over x squared plus d over x plus 1, right? So we have used this one. This is actually which type repeated, it is mixed of that. You have repeated root and this mix of type 1 and type 2. So now we are going to find out the values of b, c and d. So now you multiply again, we will use the same method. Now we have done many of them, I think that's very clear now. So this is going to be equals to b into x plus 1 plus c into x plus 1 plus d and x squared, right? So now let's say x is equal to negative 1, then we have this left hand side becomes here negative 3, and all these are 0, only we are left with d into 1. So that gives us d equals to negative 3. And if x is 0, then we will have 4 into c into 1. This gives us c equals to 4. Then we can combine the coefficients. We can have the coefficient of x squared, equating the coefficient of x squared, we got here negative 1 on left hand side here, and here we have equals to b, and then here we have d. So we have already the value of d here. So minus 1 equals to b minus 3. So this gives us value of b equals to 2, right? So we got value of a and b, and c and d is here. So we got all the values. So now we are going to that was actually the question, yeah. So a, b, c, d, so we have all got all the values. So that's it for this video, guys. In the next video we will do all the past paper questions. So if you have any question, please comment in the comment section, and please take a moment to subscribe to the channel and give your feedback and share it with your friends. Thank you so much, guys. Be blessed. Now let's learn about binomial expansion, as you will get the questions of partial fraction and binomial expansion together. So binomial expansion in AS level, you have learnt this when n is a positive integer, then binomial expansion is in this form. 1 plus x power n, then you take 1 plus nx, n into n minus 1 2 factorial till x power n, right. Now here in this A2 level, you need to know more when n is not a positive integer. So what will happen if n is necessarily not a positive integer? So it may be a fraction, or it may be any integer, and x is modulus x is less than 1. So this expansion x 1 plus x power n is 1 plus nx, n into x, n minus 1 2 factorial x squared, and then you again continue n minus 1 n minus 2 over 3 factorial x cubed. Now what happens when x is a positive integers, meaning here let's say we have 1 power x plus n is any positive integer, maybe let's say I'm taking the bigger number is 15. So your term will end somewhere when x is 15, but when we take x is not a positive integer, so it may be a negative or it may be a fraction. So then these terms you will see are going to continue, right. We will learn later on this. So now if we use this one here, I'm taking one example, expand 1 minus 2x power negative 2. Now our n here is a negative number, it's negative 2 in ascending powers of x up to and including the term in x cube. Simplify the coefficients. So we will use the same rule here, 1 plus xn. So I'm writing here 1 minus 2x power negative 2. If we compare this expansion here, which is 1 plus x power n, so our here in this case we are getting x equals to negative 2, right. So x equal to negative 2x, this is our x now, meaning instead of x we have negative 2x. So that's what I mean to say. And then our n is negative 2, which is a negative number, okay. So this expansion is 1 plus nx plus n into n minus 1 over 2 factorial x squared and so on, right. So we will expand this like 1 plus n. Now our n is negative 2, nx, x is negative 2x, plus then n minus 1. So n is negative 2 and n minus 1 negative 2 negative 1 over 2 factorial. That means I'm just writing first it's 2 factorial, and then here n x we have done here the second term, then we have x squared. So x is now 2x and square of that. Then the third term n is negative 2, then it will be negative 2 negative 1 n minus 1, then n minus 2 over 3 factorial and x power 3, meaning 2x negative 2x power 3, and continue, right. So as n is 2 and x is negative 2, we have just replaced that in this formula that we have here. So now we are going to expand this. So this is 1, when you solve this, this is gonna be plus 4x and plus this is negative 2 negative 3 over 2 times 1, and here we have 4x squared, and then plus we can write it down, this is negative 2 negative 3 negative 4 over 3 times 2 times 1, that is 3 factorial, and we have here 2 times 2, it's negative 8, 2 times 2 times 2 8 x cubed, and we will just put dash dash. So further simplify this one, 1 plus 4x plus this is going to get cancelled, 4 times 3 12, positive 12x squared, and similarly we solve this one, this all you can see becomes positive, and you multiply, this 3 is gone, this 2 is gone, So 8 times 4, it is 32, and x cubed, right? This is what we got. Now the question is, expand this to powers, ascending power. So we have done it is ascending powers of x up to and including the term. We need to expand it until x power 3. This is how you will be given conditions, because otherwise there is no end of this expansion. So he told us to do it until x power 3. So we have done it until x power 3. Now by definition, this is very important, that an x, this we have here, mod x is less than 1. So this is going to be valid for only, we need to give the values. Our x is now negative 2x is less than 1, or we can say that this is going to be negative when you divide it by 2 is less than or less than a half. So this is the condition that this expansion is valid for it, right? So I hope that's clear now. So guys, I want to request you guys, if you are new to channel, kindly subscribe and share it with your friends, and please take a moment to give your feedback in the comment section, so it will help me to know the next step that I need to take. Okay, so let's take another example. We have expand 1 minus x over 2 power 1 over 3 in ascending powers of x up to and including term till x3. Again we are writing in ascending power and including x cubed. So we need to stop when we get x cubed. Then there is second part, we will do that later. Now let's start with part A. We have 1 minus x over 2 power 1 over 3. So now our n is a fraction, right? And instead of x, x is now negative x over 2. If I compare to the formula, we are going to use that expansion again, that we have 1 plus x power n is 1 plus nx plus n into n minus 1. You will be given this in your MF19, the sheet that you will get. N minus 1, n minus 2 over 3 factorial x cubed. So we are writing until x cubed, right? By using this, we will have this expansion is going to be 1 minus x over 2 power 1 over 3. So 1 plus nx, n is 1 over 3 and x is negative x over 2. I will recommend that you always write these numbers in bracket, so that you don't miss out any of the sign. This topic is not hard actually, but the calculation sometime, if you mess up, then it's gonna give you trouble. So 2 factorial and then negative x over 2 squared. Then we have n again 1 over 3 and minus 2 over 3. When you subtract, I'm directly subtracting, and minus 2, it's gonna be minus 5 over 3 over 3 factorial and x cubed, right? So now we will rewrite this. 1, when you open this and this, is going to be minus x over 6. Then we have plus, here we will get 2 negative 2 over 9, and over we have 2 times 1, that is the factorial, and also we have x squared will this becomes 4, then plus 1 over 3 over 3 times 2 times 1. Sorry, I missed out here, x not x cubed, x is going to be replaced here by this was x is now x is negative x over 2 cubed. So this is going to be minus x cubed over 8. Now we can write it down, rewrite x over 6 minus 1 over 36, it becomes 9 times 4 36. This 2 and 2 will get cancelled, so x squared and then minus 5 over, so this is gone, this is going to be negative 5 over, it becomes 648 when you do the calculations, x cubed plus so on, right? And provided, meaning our it is valid for minus x over 2 is less than 1. This is by definition. So this gives us, when you take it, it's going to be, you multiply it by 2, it's gonna be negative x less than, it will become 2, and then minus 2 less than x less than 2. So this is the validity of this number, right? Now the B part, use your expansion. So we are using this first expansion to evaluate this. So your answer is supposed to be 6 decimal places. So let's do that one. So part B, we have here, let us say we have 1 minus x over 2 power 1 over 3. This is equal to 0.999. This is what we are given, cube root of this. So this can be written as 1 minus x over 2 power 3. So I can write it in the same form, it's 0.999 and power 1 over 3. So now you can see both sides powers are same. So that means the inside the bracket it's going to be same. 1 minus x over 2 is equal to 0.999. So from here we can find out the value of x. So 1 minus 0.999 equals to x over 2. So from here we are getting x is 0.002, right? So once we got the value of x here, so we can substitute that in the expansion that we got in the first term here. So I am taking this equation, the expansion that we got in the first term here, this one is 1. So from 1 we have 1 minus x over 6. So as we know that our expansion of 1 minus x over 2 power 1 over 3, we have the expansion 1 minus 1 over 6. I'm just rewriting it from there. 36x squared minus 5 over 6, 48 x cubed, right? Now our x is 0.03. So replace your x by 0.002. So I get this one is going to, this as we have done, this is equal to 0.99. It's gonna be 1 minus 1 over 6. Your x is 0.002, then minus 1 over 36 and 0.002 squared minus 5 over 648 x cubed 0.002 cubed, right? So now you need to be careful doing these calculations. So this is coming 1 minus 0.000333. Be exact, okay, because we are looking for 6 decimal places. So next is 0. I'm getting here 1 2 3 1 2 3, then there is 111 minus 0. You have to be very careful doing these calculations, yeah. 0 0 0 2, this is what I got. So now plug in all these things in calculator and I'm getting here 0.99, then I got 665293, and to 6 decimal places we need answer up to here. So this is going to be 0.99966, and as you see this one is greater than 5, and then this will become 5 or greater is this to 6 decimal places. So this is how you will do this question, right? Now next we have binomial expansion of the form ax plus n, a plus x power n, where n is not a positive integer. So it's the same sequence like in the series of when n is not a positive integer. Now we consider the expansion when it is of the form this where a is not equals to 1. So previously we have done this expansion. We will use this one 1 plus x power n that we have done just now, and now our this a is a instead of 1 we have a. So then what to do now for any integer and the fraction still this is like the by the definition that will be applicable to that also. Now the first term in the bracket is not 1, so what we will do, we will take out this a common from inside, then making it this. If you see here, when you take out a common, this is gonna become 1 plus x over a power n. So let me show you here. So if I have here this one here a power x n, so when you take this a out from here, so this there on top there is n, so then we will have inside 1 plus x over a n power n. So now this we will use like the previous method with our, now instead of x we have x over a. So then you will see entirely every inside the bracket everything will remains the same, the only thing it will be multiplied by a power n outside. Now let's understand this with these examples. So there are 3 different kind of examples, so they will help you to know. So we have this a, express this in this form. So first question as we have is 5 minus x power negative 3. So now when I take out this common, so it's always useful to use square brackets, that it will be helpful to write it clearly. So this is gonna be 1 minus x over 5. Then on the outside there is a power negative 3. So now this negative 3, remember that it belongs to 5 as well and also to the this your bracket as well. So that means 5 minus 3 power minus 3, and we will have here inside 1 minus x over 5 power negative 3. So this is 1 over 125 and we have. So now we got it in the same way, then we can use our rule from rule that of the binomial expansion on this. Now our x here is negative 5 over x over 5, right? So I thought that's very clear. Now let's see the next this part. Now this can be written as 2 minus 6x and then power we have half. So again we will use the square bracket, so taking out 2 from here, so then inside I will have 1 minus this is going to be 6 over 2x and half, right? Sorry, this half again is outside. Remember that we are not leaving it only with the one part of the bracket. So this is a half. So now this half belongs to both 2 as well as to the bracket. So that means it is 2 power half, and inside we have 1 minus 3x power half. So this is the of the form a n 1 plus x n. Now we can proceed further with this. We will do later the examples related to that. So now this one here, if you see this our expression is in the denominator, so we can get rid of that denominator. I can bring it up here. So 2x power minus 2, right? So that's clear. Now 32 is already outside there. Remember, it doesn't have anything to do with negative 2 power here. So when I take 4 common, so it's gonna be 1 plus 2 over 4x and power is minus 2. So now 32 remains as it is outside. Inside we have 4 power negative 2 and 1 plus this is half x power 2 or negative 2, and just write here. Now we can remove this square bracket. So this is 32 and this is going to be 1 over 4 times 4 is 16, 1 plus half x power minus 2. So finally we have 16 times 2, it's 32. So 1 plus 2x. See, now this is of this form a n 1 plus x n. So then we will proceed it with the binomial expansion that we have learned before, right? So here is the summary that you have learned until now. First of all, you need to split the partial fractions. You need to recognize, are they of type 1, type 2, type 3 or 4. So here are the expansions. You can just get a screenshot and it will be helpful for you guys. Then we have also learned the binomial expansion of the type 1 plus x power n when n is not a positive integer. So this is the expansion. This goes, and this condition is always applicable. And then of a plus x power n when n is again not a positive integer. So first we will take out a n and then we are going to proceed. Then now we have binomial expansion and partial fraction. So we can use partial fraction to simplify the expansion of complex expression. So in your examination you will see the combination of both partial fraction and binomial expansion, and this is very important, and some questions you will even see of that of 10 to 12 marks. So be careful about all these rules and then do practice with past paper. So let's do some past paper questions now. So we have a question here, express this in partial fraction. So the first thing, you need to note down the degree of numerator and degree of denominator. So degree of numerator is 2 and degree of denominator is also 2. So this is an improper fraction. So we need to divide this, right? So we, by using this division method, we are going to divide this. I'm dividing 6x squared minus 9x minus 16 by 2x squared minus 5x minus 12. So here we need 6x and we have 2x here, so we will multiply by 3. So 6x squared 5 times 2, this 3 is gonna multiply to everything here, and then we write it down here. 5 times 3, it is negative 15x. 12 times 3, it's 36. Now you change the signs of the lower equation when you subtract. So this and this gets cancelled. 15 minus 9, it is 6x and plus 20. So this is our remainder. So now this fraction can be written as 2x squared minus 5x minus 12. This will be written as 3 plus 6x plus 20, the remainder, over the divisor, 2x squared minus 5x minus 12. Now this can be factorized. This 2x squared minus 5x minus 12, this can be factorized here. So the factors of this is 2x plus 3 and x minus 4, right? We will use this one. So this is gonna become 3 plus 6x plus 20 over, we have 2x plus 3 and I have x minus 4. Now the first part is same and we are going to use the partial fraction, this is splitting, on the second part. So now if you see here, let me go back. So we have here the linear part on the numerator and denominator, we have two factors. So this is of type 1. If you see, this is of this type, so we will be using this. So this is a type 1 partial fraction, right? Then we can split into this again. I can write it down. I'll just take this part only this part. Let me take this is equation 1. So now I'm just taking this one, 6x plus 20 over 2x plus 3 x minus 4. So this will be equals to a over the first factor, that is 2x plus 3, and plus b over the second factor x minus 2. So we will multiply this to get the values of a and b on the right hand side. So this is going to become a into x minus 4 and plus b into 2x minus plus 3. So this is minus here. Okay, so now we are getting the values of x and a and by substituting the values of x. Let's say x is 4. When our x is going to 4, this is going to become 0. So we have 6 times 4 plus 20, and this is first term is going to become 0, and plus b into 2 times 4 plus 3, right? So here we got 44 equals to 11b. So that means our b is 4. So we got the value of b as 4. Now similarly we can get the value of a by substituting x equals to negative 3 over 2. So you always go here whenever you want to know how to substitute the value. So like here we have 2x, the second factor 2x plus 3, we want this to be 0. So you can get from here x equals to negative 2. This is negative 3 over 2. This is how we define the value of x, right? So now let's go back. So once you substitute this one here in this second equation, so we will have 6 times negative 3 over 2 plus 20 equals to a, and then we have minus 3 over 2 minus 4 and plus 0. Second term is going to become 0. So this is 2 times 3, 3 times 3, 9. It's gonna be 11 equals to minus 11 over 2a. So from here our a is negative 2, right? So we got the value of a and b. So now we substitute all these values in equation number 1 from here, right? Then to get the final answer. So from equation 1 we have 6x squared minus 9x minus 16 over we will just write the original in the beginning what question you had, minus 12 equals to 3 plus a is now 2, so I'll put 2 here, 2x plus 3, and b is 4 and x minus 4. So this is our final answer. Okay, so now next we have here express this in partial fraction. So whatever you see, whatever question you see, the first thing that you need to know the degrees of numerator and denominator. Here degree of numerator is 2 and degree of denominator is also going to be 2. So again this is an improper fraction. So we are going to divide it, right? So first I'm dividing this 6x squared minus 2x plus 2. So we have to expand down the fraction here, the expression here, 6x squared minus 2x plus 2. Expanding this, I got here 2x squared minus x minus 1. So we will divide by this 2x squared minus x minus 1. We need 6x squared here, so we are going to multiply here by 3. So when you multiply here by 3, I'm getting here 6x squared multiply throughout, then minus 3x minus 3. So now changing the sign of the lower equation, this is going to be minus, plus and plus. This was 2, so this and this is cancelled, so 3x minus 2x is x plus 5. So we got remainder x plus 5. So this equation 6x squared minus 2x plus 2, I will again go back in the form of the factor because eventually we need the factors there. So this is going to be 3 plus x plus 5 over 2x squared, that is the factors again, we can write the factors over x minus 1 and 2x plus 1, right? So this is our equation 1. So now we will be applying on this second part, the second term, the partial fraction. So again, if you see, this is of type 1, right? The one that we did before. We have a linear expression in the numerator and 2 factors in the denominator. So we are going to expand this, the second term, like this. So it is x minus 1 and 2x plus 1. So this is going to be a over first factor, that is x minus 1, plus b over the second factor. So again we will cross multiply this denominator on other side. So we will have here x plus 5, and then we have a into x 2x plus 1 and plus b into x minus 1. Using same way, we will make the these one of the coefficients of a and b 0. Then we will find out the value of a and b. So if I take x equals to 1, let's say I'm taking x1, so then left hand side is 1 plus 5 equals to a, 2 times 1 plus 1 and plus this is gonna 1 minus 1, second term is going to become 0. So this is 6 equals to 2133a. This gives us a equals to 2. Okay, now we define another value. We can suppose, let's say x is negative 1 over 2. As I told you, you just substitute this. I like 2x plus 1, we want to make this 0, so then we will have x equals to negative 2. So then we have minus 1 over 2 plus 5 equals to a into minus, this is minus 2, a is 2 times minus 1 over 2 plus 1 and plus b into minus 1 over 2 minus 1 from this equation number 2. Basically this is going to become 0 here, this first term. So this we have 9 over 2 will be equals to b into negative 3 over 2. So this gives us the value of v as negative 3, right? So now we are just going to use the equation 1 to expand this, so that once we got the values of a and b, so we can write the final answer. A 6x squared minus 2x plus 2 over x minus 1 and 2x plus 1 equals to 3 3 plus 2 over x minus 1 and minus 3 over 2x plus 1. So this is our final answer. Okay, now let's do this next question. This is question from October November 2022, paper 3-1, right? So this is question paper 3-1. This is question number 10 from that paper. So let's do, as we see here, we have the quadratic in the numerator and denominator as well. So here you see we have square outside, so this is a repeated root. So first of all we need to see the degree of the numerator and denominator. So if we see here, the degree of the numerator is 2 and degree of the denominator is 3. So this is a proper fraction, right? So one thing is clear, that we have this is a proper fraction, so there is no need to divide. Now one root, we have two factors here, one is 1 plus x, another one is 2 plus x power 2. So that means this is a repeated root, right? So you are going to get the same root. So let's go back, let me show you the summary that we did. When you have a repeated root, what do you take when you do the partial fraction? Here we have the type 2, so it is type 2 repeated factor in the denominator. So we have this. Now this basically is combination of type 1 and type 2, because we have two factors and one of them is repeated. So we will first expand it like this, a plus b, then we will take the third term as a repeated. So let me write down here. So we have here 2x squared plus 7x plus 8, and we have 1 plus x and 2 plus x squared. So first we have two factors, so that means a over first factor and then b over the second factor, but we will take it only as power 1. Sorry, this is b here, and then plus c we are going to take as a repeater, 2 plus x squared. So this is our equation now we will find out the values of a, b and c by the same method as we were doing before. So we are multiplying throughout by the denominator. So we got here 2x squared plus 7x plus 8 is going to be a. One factor is cancelled, so we will have here a into 2 plus x, do this step carefully, and plus b. Then this two factor, one of them is going to cancel, but still we will have another one, 1 plus x and 2 plus x with the b. Now with the c, this factor is going to cancel and we have 1 plus x. So this is the equation after multiplying the denominator throughout. So now we will make one by one these terms 0 that are with a, b and c to get the value of these constants. So now let's say first of all I'm taking here x equals to -1. When we take x -1, so left hand side is going to be like this. So please take your time to write all these. Sometime a single mistake will cost you a lot, so don't skip the steps. So there is no harm in writing all the steps there. So we have plus, then -1. When we put -1, 1 minus 1, this is going to become 0, and the other part is also going to become 0. So basically we are going to get value of a from here. So this is 2 minus 7 plus 8 equals to, this is a. So this is 8 plus 2, 10 minus 7, it's 2. So sorry, 3. So value of a is 3. We got the value of a equals to 3. Now let's substitute another value. So now we have another factor here, 2 plus x. So we can substitute value of x as equals to -2. So left hand side is going to be -2 squared plus 7 times -2 plus 8. We are still using this second equation to find out the values, equals to a. Then we have 2 minus 2, this is gonna become 0 basically, and then we have b into 1 minus 2, and this is also 2 minus 2, this is gonna become 0, and you can even skip this, just write here 0. Okay, so what do we have here? So this is gonna become 8 minus 14 plus 8 equals to, this is 0 plus this is 0 and this is -1c. So 8 plus 8, 16. This is gonna go be 2 minus c. So that means our c is a -2. So now we are left with only the value of b. So now if you look around again in this equation 2, so if we put, let's say, we can even put x0 so that we get the value of a. So let's say x is 0. So then left hand side we are going to have only 8 here. Yeah, and then we have a into 2 plus 0 power 2, and then plus b. We have here 1 plus 0 and 2 plus 0, and then c 1 plus 0. So this you can also equate the coefficients, that will also be helpful. It's up to you how do you want to do that. So this is 2 times 2, 4a. Yeah, and plus we have this is 2b, and then we will have here plus c, right? So now we will substitute the values that we have. We have the value of a, which is 3, and we have value of c, which is -2. So this is 8 equals to 12 plus 2b minus 12. So this gives us the value of b equals to -1. So we got the values of a, b and c. So substitute all these values in this equation 1 here to get the final partial fraction. So we have here 2x, the function is going to be you can directly also write down that fx is equal to now 3 over 1 plus x minus 1 over 2 plus x and minus 2 over 2 plus x squared. So this is the final answer of part A. Now if you see, this question is of 5 marks here. So one part is of 5 marks. So do all the steps carefully and then you can move to the next part. So now let's see what is the next part. We have B part again as well. You see, this is also 5 marks. So in total you will get this 10 marks question. So here obtain the hence obtain the expansion of fx in ascending powers of x up to and including the term x squared. So here we will apply the binomial expansion as I told you before. So fx, we will take the expansion of the fx that we get in the first term. So fx we have here from the first part, we got here 1 over 2 plus x, and we have minus 2 over, so we have 3 different terms here. Okay, so now we will apply the binomial expansion to these 3 different. So if we can bring this, I told you, if you get this in denominator, your factors, you can bring it up here. So we can write it down minus 1, then we have 2 plus x power minus 1 minus 2 into 2 plus x power squared. This one is minus 2 here. So now we can add one more step here, because this is of 1 plus x form, this is a plus x form, and this is also a plus x form. So we can take out 2 common to make it 1 plus x form here. So 3 into 1 plus x -1, it remains as it is. So 2, we will take out 2, but then there is -1 outside. We have here 1, then it is x plus 2, this is going to be -1, and then I have here 2 outside, and then another 2 will come from here, 2 power -2. So inside we will have 1 plus x over 2 power minus 2, right? So now we can have one more step here, 1 plus x -1. So this is going to be minus 1 over 2, 1 plus x over 2 power minus 1, and this is going to become 1 over 2 and 1 plus x over 2 power minus 2. Now we can apply binomial expansion. Now for the binomial expansion we have 1 plus nx plus n into n minus 1 over 2 factorial x squared. This is the expansion of 1 plus x power n. So we are taking up to square because we are given in the term that you need the term up to x squared, right? So we will be using this formula here. So then our fx becomes, we are going to apply one by one all this formula. So I will try to separate them by colors. So the first one here is we have here 3, and then at inside we have 1 plus nx, 1 plus n is -1, and x is our x as usual here, and plus n minus 1, we have this n into n minus 1. So n is -1, n minus 1 again over 2 factorial x squared, right? So this is our first term. So if I split this further, if I solve this, I will do here along with this one. Let me put a bit of gap here. So here this term becomes 3, and then we have here 1 minus x, and then this is -2 times -1, it's positive 2 over 2, it's gonna cancel with this, so plus x squared. So this one is sorted out. Now let's go to the next one. So next one if I choose this color. Okay, so the second term here is this one. So this was actually minus 1 over 2 remains outside, and inside we have 1 plus nx. 1 plus n is negative 1 and x is x over 2. 1 plus nx, then n into n minus 1, minus 1 n minus 1 over 2 factorial into x squared, x over 2. X is now x squared over 2. So this is done. So now we will simplify this. This comes out here 1 over 2, and inside we will have here 1 minus x over 2. Then this becomes 2 and 2 gets cancelled, so we have only 1, and then here we get x squared over 4, right? So this is x squared over 4. So this is our second term. Now let's go to the third one. So the third one here is our this term, right? So this is going to go here, minus 1 over 2, then again it is 1 plus nx, 1 plus, now n is negative 2 and x is x over 2, then plus n minus 2, n minus 1, n is it's gonna become minus 3 over 2 factorial, and then we will have x squared, meaning x plus my x over 2 squared again. So when you simplify this one, this is going to become minus 1 over 2, and we have here 1, and this gets cancelled. We have only minus x left here, minus, then this 2 and 2 gets cancelled, 3, and here we will have over 4. So this will be plus 3 over 4 x power 2. So now it is sorted out. So look at the color this scheme, then you will understand the calculations. Now we can just expand the brackets, and now just the algebra part is left. So let's do that slowly. So here we have 3. When you expand, 3 minus 3x, this was squared, sorry, here. So plus 3 x squared, right? Then I have minus half plus x over 4 minus x squared over 8, right? Then expanding this one here, minus 1 over 2 plus 1 over 2x minus 3 over 8x squared. So now we will combine the like terms. So combining the like terms here, so we have this and this. These are the three different terms when we opened. Combining the like terms, I'm just taking the constant of all these. So this is 3 minus half, then plus I'm taking terms of x, negative 3x plus 1 over 4x plus half x, and then I'm taking x squared terms. We have 3x squared minus x squared over 8 minus 3 over 8 x squared, right? So now you just simplify this, and this is 1, 3 minus 1 is 2, plus then we can have LCM, it's 4, it's negative 12x plus x plus, I think you can manage it now it's just the algebra part, but be careful while doing the calculations. This is 24x squared minus x squared minus 3x squared. Okay, so I got here 2 minus this becomes 9 over 4x plus 20 over 8x squared. Now we can simplify this one. This is 2 minus this is 9 over 4. We cannot split this, but these both are can be divided by 2. I mean 4 times 5, 4 times 2 x squared. So this is our final answer. That gives us the terms up to, that includes a term in x3, x squared. So we got first 3 terms. Okay, So we have this another question from October November 2022 paper 3-2. So the question is, we have 4 minus x plus x squared over 1 plus x 2 plus x squared expressed as partial fraction. Now let me show you the difference. This one here, the square is inside the bracket, so we have 2 plus x squared, right? It's like a quadratic function. So in the previous question we had the square, it may look the same. You have here 2 plus x, the square is outside the bracket, so that's why this was a repeated root. But now this is not repeated, but we have here the quadratic. So for that, when we get this kind of question, we have, let me go back to the summary here. So this one here, you see the type 3. So this is type 3. Now you have a one of this quadratic factor in the denominator can be split. So one factor and then another quadratic factor. So we are going to use this one, a over x plus b, this one, right? So let me go. So let's do that by splitting this. So fx is going to become, so this is our fx is going to become a over first function, first expression, and then bx plus c over the second quadratic expression, like this, right? Fx is 4 minus x. We need to write down this, sorry, because we are multiplying. 1 plus x is equal to a over 1 plus x and plus bx plus c over 2 plus x squared. Now again you cross multiply the denominator, you multiply throughout by 1 plus x square x. So 4 minus x plus x squared will be equals to a into, sorry, I missed this factor here, 2 plus x squared, right? So a will be 2 plus x squared here, and plus bx plus c, in bracket we have 1 plus x, right? Now we will find out the values of a, b and c by different methods. So let's say, first of all, I'm taking this as equation 1. So let's say x is equal to -1. So the left hand side is going to become 4 minus minus 1, then plus minus 1 squared equals to a into 2 plus 1, -1 square is 1, then plus it will become minus b. We are taking x as -1, and then plus c, and this is going to be 1 minus 1. Basically it's going to become 0, this whole thing. So here we have on the left hand side we have 6, and this is going to be 3a. So this gives us the value of a equals to 2. So constant a is a 2. Now let's substitute another. Sometime it's not possible to get the positive, the 0. So you can simply just take some values, then we will get the equations in terms of a and b and c, then we can find out different values. So x is 0, so x 0 left hand side becomes 4. So here this is going to become, x is 0, it is 2a, and plus this is x 0, this will become only c, 2a plus c. So a we already got here, it is 2 plus c. So basically c is equal to 0, right? Now let's take x equals to 1. You will learn with practice how to get these values of x. So 4 minus 1 plus 1 squared is also 1, 2 into 2 plus 1 squared plus b times 1 plus 0 into 1 plus 1. So this is basically, this is gone. So we have 4 equals to 3 times 2 it's 6, and plus 2b. So from here we got b, actually 2b will be minus 2 and b is going to be minus 1, right? So we got the values of a, b and c. So then we will just write down the function. So the original function fx is going to be a, that is 2 over 1 plus x plus bx. B is now -1, x plus c is 0 over 2 plus x squared. So we can just rewrite this one in a proper way. It looks nice. 1 plus x minus x over 2 plus x squared. So that is the answer of our partial fraction. Okay, now next one here, this question involves integration, so I'm skipping for it now because we are just doing focus on binomial and the partial fraction. Now let's move to the next question we have here. This is question from October-November 2023, paper 3-1. So we have this fraction given, express this as a partial fraction. Now the first thing you need to look at the degree. So degree of the numerator is 1 and degree of the denominator is, it's gonna be like you are going to get x squared from here and x from here, it's gonna become 3. So numerator is less than degree of numerator is less than denominator, so that means this is a proper fraction, so we need not to divide this. Now the second thing you need to know about the denominator. So denominator, we have the combination of mix of linear factor, this is a linear factor, and a repeated factor. This is repeated because square is outside the bracket. So let me take you back here to the types here. So we have the mix of this repeated factor and the linear factor, right? This is linear factor and repeated factor. So we will have these two factors, then the repeated factor as well. So we will take this as let me rewrite combination of the linear factor and the repeated factor. So 24 plus 13, we have here 1 minus 2x, then we have 2 plus x squared. This is going to be a over 1 minus 2x, then plus b over, we have 2 plus x, one of these factors, and c, then the square of this factor, right? So this is this actually step is very important. Once you get this correct, then there are simple steps. Now multiply this throughout by the denominator of left hand side. We have 24x plus 13 is going to be equals to a, there will be 2 plus x squared, then b, we will have 2, this is gonna get cancelled, we will have 1 minus 2x and one factor will still remain there, 2 plus x, then c, this the whole is gone, we will have the other factor 1 minus 2x. So this is our equation number 2. So now we will substitute the values of x randomly, and if I substitute x 0, then I'm gonna get rid of this part, this is going to become 0. So left hand side we have 24 minus 2 plus 13 equals to 0, and plus this is also going to give us 0, and then we have c 1 minus 2 times minus 2, right? So this is negative 48 plus 13 is going to be 4 minus 1, this is gonna be 5, this is positive 4, this will become 4 and plus 1 5c. So this gives us c equals to 35 over 5, and this is negative, that is negative 7. So c is negative 7, right? Now we can substitute another value of x. So let's say now we have x is equal to half, then what will happen? So this is 24 into half, we are using second equation, plus 13 will be a into 5 over 2, it will become 5 over 2. When you substitute here this x as 1 over 2, 2 plus 1 over 2 is going to be 5 over 2, and then here half, this is going to become 0, this is going to become 0, so both of them are going to become 0. So I have here, this is going to be 12 plus 13 equals to 25 over 4a. So then a is 25 times 4 over 25, so a is 4. right? So we got the value of a. Now let's say we can put x is 0. This is another option whenever you don't get another this value to make one of the factors 0, so you can just take x 0. So then left hand side will have 13 equals to a, and we have 2 plus 0 squared, and then b it will become 1, then this is 2, and c 1 minus 0. So we have 13 equals to, this is going to become actually 4a plus 2b plus c. Now we already have the values of a and c. So 4 times minus 7, and 2b and c is negative 7. Okay, so sorry, a is 4, this is 4 here. So 13 minus 16 plus 7 is equal to 2b. So we get b equals to 2. So we got the values of a, b and c. Now I hope you guys understood everything now, how to split these partial fractions. So please take a moment to give your feedback in the comment section while we are doing these questions. So kindly subscribe to the channel and also share it with your friends if you are getting benefit of these videos. So this is our final answer, right? Now, so this question was of 5 marks, right? Now another, these are 2 follow-up questions here. This is also 5 marks, then another one is of 1 mark. So let's do this one. So here we are going to use the binomial expansion. Now hence obtain the expansion of fx in ascending powers of x and including the terms up to x squared. So meaning we are looking for, we will use only first 3 terms, because the third term gives us x squared, right? So now if I take this one here, I'm taking fx from the, when it says hence, so that means we are using previous part. So I will take this equation fx in the end that we got. So let me rewrite this. I will write down that in the numerator 1 minus 2x power minus 1, then plus 2, and this power negative 1 minus 7, 2 plus x power minus 2, right? So now in the previous question I showed you it by doing all together in as here, but here I'm showing you like to split this. Like let's say this is our first, this is the second term, and this is the third term. So we will try, we will solve them separately and then we are going to add them together. So the first one that we have here is so it is 4 into 1 minus 2x minus 1. So the first thing you need to know, see that when we do binomial expansion we are using this 1 plus x power n, right? So which is equal to 1 plus nx plus n into n minus 1 over 2 factorial x squared, right? We will use first 3 terms. So here we already have 1, so we are not going to do anything, just going to expand it with the binomial expansion. 4 into 1 plus minus 1 to minus 2x, then plus minus 1, and this will become negative 2 over 2 factorial. Our x is now 2x and squared. So I'll stop here because we just need up to square. Then you expand, I mean the simplify, 1 plus 2x plus 4x squared and so on. Now you multiply 4 inside, 4 plus 8x plus 16x squared. So this is our first thing, right? Now the second one, second term we have 2 into 2 plus x power minus 1. So I'm going to see, now this is not 1 plus x form, so we need to take out 2. This 2 is already there, but there is another 2 which will come as 2 power minus 1. So this 2 power minus 1 will come outside here. Inside the bracket we will have 1 plus it is x over 2 and we will have -1. Now we are going to expand. This 2 and 2 gets cancelled here, so we will have here 1 plus, it's -1, and 1 plus nx plus n minus 1, that will become -2 over 2 factorial, and x is now x over 2 squared. So this is 1 minus x over 2 and plus x squared over 4, because this is gonna get cancelled here and this minus minus is plus. So this is our second term. Third term, now we will go for the third term. So the third term that we have here is it is 7, -7 and 2 plus x power -2. This is again not 1 here, so we are going to take out 2, that is going to be -2. Inside we will have 1 plus x over 2 power -2. Now we are going to expand this. This is going to become actually 7. It is going to become -7 over 4. Then we have 1 minus, this is going to become 1 plus nx, actually n is -2 and x is x over 2 nx plus n minus 1, n minus 1 over 2 factorial, and we have then x over 2 squared, right? So when you do this one is going to become, I'm bringing it here, -7 over 4, it's 1 minus x plus 3 over 4 x squared, right? Now we are going to multiply this outside this one, 7 over 4 inside, sorry. So then it is becoming -7 over 4 plus 7 over 4x and minus 7 times 3, 21 over 16 x squared. So this is our number 3. So now we are going to add 1, 2 and 3. So when you add 1, 2 and 3, so I am writing here 4 plus 8x, all these terms together, then we will combine. So 1 minus x over 2 plus x squared over 4, then plus minus this 7 over 4, and continue the same way. Now you combine. When you combine, I'm just writing it directly, I don't have enough space to write. So constant term I got here 13 over 4. I added 4 plus 1, 5 minus -7 over 4. Similarly, terms of x, then we get it's gonna be 37 over 4. This is just the algebra part, plus 239 over 16 x squared. So this is our final answer. So this was also 5 marks. Now there is another follow-up question here. State the set of values of x for which the expansion b is valid. So as I think you remember, let me show you when we did this one here. So these are valid, these expansions are valid when mod x is less than 1. So this is our x. Now we will see in the question we have 3 different terms here. So you are going to look here, let me show you. You are going to look at this part where we have converted this into this one. So here in the first one we have -2x, so meaning this -2x should be less than 1, right? So I'm writing here, so this mod of -2x should be less than 1. And we have another term as well here. This one is when you splitted here, this here x 1 plus nx. Now n is x over 2, and also in this case also x is n over 2. In those the last two we have same value of x over 2 should be less than 1. So these are the two conditions. Now we will combine. So as mod x here, when you divide, is gonna become 1 over 2 because there is a modulus, so we will remove the sign of negative. So this is going to get less. Now when you combine these two, what will be the result? So this is x0, this is x1, x2, and half is somewhere here, right? So values are less than this and less than this. So if I combine with this half, then it will cover all the values, right? So by combining, the final answer is x is less than half, right? So that's it for this question. I hope you understood, because this question covers everything. So you do it and let me know in the comment section if you understand that, and also kindly subscribe to the channel and share it with your friends. Okay, so let's see the next question we have here. Express this in partial fraction. So and until now you must have learned about how to recognize them as linear and quadratic factors of the denominator. So now first thing that we see, as I told you before, you look at the degree. So the degree of the numerator here is 2 and the denominator is, it's gonna be 3. Here x square and x cube, x square times x is gonna become 3. So it is a proper fraction, so we have not to divide that, right? So now for the other part, for the denominator part, so let me rewrite first here. X 17 x squared, 7x plus 16 over we have 2 plus 3x squared, and then we have 2 minus x, right? So now recognize the denominator. As you can see, we have this quadratic factor here. So I can just rewrite this one as let me 7x plus 16. I can write the linear factor first, then we will write the quadratic factor. That's how usually we write. So we have the this of the type, actually this one here, the quadratic factor here. So it is like this. So we will use this decomposition here. So we have to write here a over first factor, which is 2 minus x, plus then bx plus c over the second quadratic factor. So I can write it down 3x squared plus 2. I'm just writing constant behind. So now from here we will again multiply the denominators. Now I think you can manage, as you have learnt from the previous question. So this is going to be 3x squared plus then we have bx plus c, and then we have 3x squared plus 2 is going to get cancelled. Sorry, this is going to get cancelled. We will have here the 2 minus x. So this is our first equation, this is our second equation. So now we will find out the value. So let's say our x is 2. So when x is 2, this term is gonna go 0. Sorry, x is 2. When x is 2, then this is going to become 17, and then 2 square minus 7 into 2 plus 16 equals to a, then 2 plus 3 into 2 squared plus 0, right? So this is 68 minus 14 plus 16, 2a oh wait, we can just, this is 4 times 3 12, 12 plus 2 it is 14a. Okay, so from here I got here, this is 70 and 14a divided by 14 divided by 14. So we got the value of a as 5. So this is our value of a. Now let's say our value of x is, let x we are substituting as 0. So this is going to be 0 minus 0 plus 16 equals to a into 2 plus 0 plus 0 plus c, then 2 minus 0, right? This is what we got. So we have here 16 equals to 2a, a is 5, I can put 5 plus 2c, right? So this is 16 minus 10 equals to 2c, and this gives us c equals to 3, 6 over 2, that is 3. Now let's say we have x equals to 1, so we can substitute x1. Then we will have 17 my 1 squared minus 7 into 1 plus 16. Just I'm substituting this in equation number 2, these values. So then a into 2 plus 3 plus b into 1 plus c and 2 minus 1, right? So this is 17 minus 7 plus 16 equals to 5. Sorry, it's 5a. It's 5a plus it's gonna be b plus c, and this is 1, right? So this comes out to be 1 here, and we have b 5. A is 5. Wait. So this was 1. So when you do this, this is 26, and 5 times 5, and then plus b plus c, right? So 26 minus 25 equals to b plus c. C is now 3, so this is 3. So this gives us b equals to 1 minus 3, that is 2. B is a negative 2. So now we got the values of a and b, so we will substitute in equation 1. So from equation 1, therefore our function is going to be 5 over 2 minus x plus negative 2x plus 3 over 3x squared plus 2. So this is our final answer after the decomposition of the partial fractions, right? So now let's see what do we have next here. If you move to the next part, okay, hence obtain the expansion of fx in ascending powers of x up to and including the term up to x cubed. So we are looking for third term now. So as you know that we are using the this binomial expansion, so we will take the first terms up to, like, first 4 terms that will give us up to x cube. So I'm taking from part 1. When it says hence, so that means we are using part 1. So from part a, we have our fx is equal to, fx can be written as, so now these kind of questions, guys, remember that you should not skip lines, because your working space may get you can have the problem in that. So just write it clearly. So this I have just written as the negative denominators, right? So again I'm going to split them. I'm doing this separately. So the first part that I'm taking here is this is, let's say, our first part, and this is the second term, like second part of the question. So the first one, if I take, is 5, and then I will take out 2 from here, so that will give me 2 minus 1. It is gonna be 1 x over 2 power minus 1, right? So then this is going to be we are going to use this 1 plus x power n, which is 1 plus nx plus n minus 1 over 2 factorial x squared, then n minus 1 n minus 2 over 3 factorial, and then x cubed over 3. So then I'm writing this one here as the 5 over 2. It will become 5 over 2. Then we are splitting this 1 plus n. N is negative 1 and x is now negative x over 2, right? Then plus n, which is negative 1, and minus 1 will become negative 2 over 2 factorial, and instead of x we have x over 2 squared. Remember, we are writing one more term here. So n minus 1 n minus 2, that will become negative 3 over 3 factorial. This is going to be like this, right? And so on, but we are looking for only this one. So now simplifying this one, 5 over 2, this gives us I will write it quickly now you know how to do that. So this is going to be just the simplifications, and this becomes x cubed over 8, right? First three terms. So this is going to cancel 3 times 2 times 1, and then this cancels with here, and that's how we are getting this. So let's say this is our equation A. Okay, now the second one, I'm taking the second equation here, the this here from here. So this is going to be like negative 2x plus 3, and we have 3x squared plus 2 minus 1. Now the first is just an expression, so we are going to split the apply the binomial theorem on the second part, right? So this is going to be equals to, if I write here negative 2x plus 3, then I will take out 3 common, 3 power this, and then it is going to become okay, wait 1 minute. Before we do this, let me tell you why I'm erasing this one. Okay, so as this was this is the power negative 1, right? So we have this 1 plus nx, so x term should be in the second place. That will make our formula work for it. So this is 2 plus 3x squared power minus 1, right? So now we are going to write this one. So this is negative 2x plus 3, then I am taking 2 common, and this is going to be 2 power minus 1. This is 1 plus 3 over 2 x squared and power minus 1. Now we are going to apply binomial expansion here. So negative 2x plus 3 remains as it is. So inside the bracket this is going to become 1 over 2. So 1 plus n is now negative 1, n x is 3 over 2 x squared, 1 plus nx plus plus we have here 1 plus nx. We are done with nx. Then the next term, okay, I think next terms we need not to write. Now you see why, because if you see this one here, this is going to be this, if you multiply this here to the inside the brackets, you are going to get x cubed term here, right? Another one you are going to get the nx term. So that's why we have not to write down the next term. So I'm rewriting everything to x plus 3, and this 1 over 2 can come outside, and inside we have here 1 minus 3 over 2 x squared, right? So now multiply this, expand this bracket. This is going to be 1 over 2. When I expand this, I got here negative 2x plus 3x cubed plus 3 minus 9 over 2 x squared, right? So this is going to be 3 over 2 minus x minus 9 over 4 x squared plus 3 over 2 x cubed, right? So this is our equation B. So now we will add A and B, right? So when you add A and B, so I have here 5 over 2. I'm just rewriting. You see these questions you have to write a lot in this, so be careful how do you organize your work. That's very important. Examiner should understand whatever you are writing. Your steps should be clear, that from which direction you are going. I have seen sometimes students, they do correct everything, they do correctly, but the organization of work is not good, right? So make sure that you organize your work well. So 5 over 2 plus 3 over 2, 8 over 2, that is 4. Then x term we have here 5 over 4 minus 1, that's gonna be 1 over 4x. Similarly you continue doing the other calculations, and I got this as my final answer, right? So this is the answer. Okay, I hope that's clear. Now state the set of values of x for which expansion B is valid. as we did in the previous question, so we are looking for when it is valid. So for that you need to see wherever we have converted that into 1 plus nx form. So for that we have here x minus 2, negative x minus 2. So the first one is valid for negative x over 2 less than 1, and let's see what is the next one. So the second expression we have done it here. So it is 3 over this one, 3 over 2 x squared. So this is 3 over 2 x squared is less than 1. Now we will combine this. So first of all, let's say this is x, they're going to be less than 2, and this is going to be 3x squared is less than 2, and x squared is less than 2 over 3, and then x is going to be less than 2 over 3. So by combining them, usually the lowest one is the answer. So when you combine, so our answer is x is less than 2 over 3. So this is where the this set of values that the expansion is valid, right? Okay, so we have another question here. Let fx equals to 36a square, 2a plus x, 2a minus x, 5a minus 2x, where a is a positive constant. As you can see, we have another constant here, which is a. We do not have the definite value, but we will follow the same procedure for that. So as you can see, this all the linear functions here, we do not have any. As I told you, we need to look at the degree. So degree at like the numerator is 0 here, because we do not have x term here, and down we have x cubed. So denominator is 3. So this is a proper fraction, right? So but we will use the partial fraction of type A, because we have all the linear factors in denominator. Now I think you are aware, now you have enough practice, and you can let me know in comment section how do you feel confident after watching this video on partial fractions, and let me know in the comment section what next topic you want me to do that. So we have here a over the first factor 2a plus x, and then plus b over 2a minus x, and plus c over 5a minus 2x, right? So now you cross multiply the denominator, so that we get here 36a square is going to be a into 2a minus x, because this plus x is going to get cancelled, and we have another factor 5a minus 2x, right? So write this step carefully. 2a minus x will be gone, so 2a plus x, then 5a minus 2x, then plus c into, I have here 2a plus x and 2a minus x, right? So this is the our what do you call, after multiplication, the denominator. Now we are looking forward for the value of a, b, c. So let's say first of all, if we want to make this term, let's say this term 0, so that means our x is supposed to be equals to 2a. So let's say x is equal to 2a, then what will happen? So then this 36a, it a squared remains as it is, so this whole term is going to become 0. Then plus we have x equals to 2a, this is also going to become 0. X is 2a, sorry, not 2a, yeah, it will not become 0. So b into 2a plus 2a, that is the value of x. Then we have 5a minus 2 into 2a, right? Then plus, now here x is 2a, so this value is going to become 0. So I'm just going to put directly 0. So this is 36a squared, and we got this is equal to 4a b, and we will also have this 2 times 2 4 5 minus, it's gonna be a, right? So this is 36a squared, and this side we have 4a squared and b. So divide by 4a square, divide by 4a square, right? So this is gone, so this is gone, so we got b equals to 4 times 9, 36. So our B value is 9. Right. Now we can substitute another value. The value that we have here, as let's say x is equals to -2. When x is -2, we will have 36 from equation 2. From here I'm using this one here, 36. It is going to be, the first term is going to become x is -2a. So we are going to put a into 2a plus 2a, then 5a minus 2 times -2a. Okay, then this is 0 and 0, because we have these terms that will make it 0. X is 2a and 2a here, -2a here. So we have here 36a squared, and we have this is a times 4a. This is 4 plus 5, it's 9a, right? So 36a squared, this is also the a times 36a squared. So a we got here equals to 1. So that is our value of a. Now we are still left with the value of c. So we can find out for c to make a and b other terms. If we have here, what else we can put? We have this here. So 5a minus 2x equals to 0. If 5 we want to make this equals to 0, so then our 5a should be 2x and x should be 5 over 2a. That's what we are going to get our next value. So let's say x is 5 over 2a. So then 36a square on left hand side equals to a, 2a minus 5 over 2a. Then we have 5a minus 2 times 5 over 2a plus 0. So this is 36a squared is going to be 2 times 2, 4, and this is going to be our 2. Okay, this term is becoming 0. So what are we left with then? Okay, I have left the c value, sorry. Then plus c was here, c into 2a plus 5 over 2a, and in bracket we have 2a minus 5 over 2a, right? So this is becoming 0, this is becoming 0, the second term is already 0, and then we are left with this one. So this is going to be c into 9 over 2a and minus 1 over 2a, right? So this is 36a squared equals to negative 9 over 4a squared c. So this will give us the value of c. So from here c is going to be 36a squared times 4 over 9 a squared, right? So this is gone, it is going to become c is negative 16. So we got the values of a, b and c. So therefore our fx is going to be a over, that is 1 over 2a plus x. Just put the values as we are doing in equation 1. So if you do all the questions in same format, you know, you follow the same steps, then you understand everything and it will not give you any trouble, like if you get any kind of question, right? So yeah, that's it for this question. So this question contains this integration, so I'm just leaving it. So that's it for this video, guys. I hope you guys understood everything about the partial fractions. As you can see, you will get like a combination of partial fraction, then binomial theorem and the differentiation, right? So and it's almost 10 to 11 marks question, so be sure that you have cleared all your concepts. Thank you so much for watching the video. Please give your feedback in the comment section. See you in the next video. Be blessed, guys.